Good morning, class. Can we continue to our part now? Today we can't get to use the projector. Okay, but I think a lot of you have downloaded the notes from the ULEarn, right? Okay, you can refer the notes, okay, from your handphone. Okay, so today we will look at how to solve second order. Okay, second order, because last week you have learned how to solve first order differential equation. So today, okay, starting from today, we will look at second order linear differential equation. Okay, so there are two parts. Okay, there are two parts for second order linear differential equation. So we will look at the first part today. Okay, today we look at the first part where the, okay, for example, this one, ay double time plus by prime plus cy equals to fx. Okay, this is a second order linear differential equation with constant coefficient. Okay, ABC are constants, so constant coefficient. So for chapter 2, we will focus on solving this kind of differential equation. But for part 1, okay, for part 1, this fx is 0. Okay, for part 2, fx is non-zero. Okay, so today we look at the case where fx is 0. Okay, so before you start to solve for this, okay, you have to know some basic about the solution of this differential equation. First order differential equation, it has one solution. Second order differential equation, it has two linearly independent solutions. Okay, two linearly independent solutions. So for second order, it has y1 and y2, two solutions. And these two solutions are linearly independent. Okay, linearly independent. Okay, linearly independent. What it means by linearly independent? X, EX are linearly independent. Okay. EX and E2X are linearly independent. EX with EX or 2EX, they are linearly dependent. Dependent means, okay, we can, let's say Y1 is this one, Y2 is 2EX. So this one, when they are linearly dependent, meaning that we can find a relationship between y1 and y2. So your y2 will be 2, ex is your y1, right? This is linearly dependent. It means they are depending on each other. Okay, so linearly independent, that means these are the linearly independent where we can't get to find a relationship between the y1 and y2. And these are the solutions that we want. We want something like this. We want y1 and y2 are linearly independent. Okay, and there is a way for us to check whether y1 and y2 are linearly independent or not. Okay, that is a Wronskian function. Okay, Wronskian function, we denote it by W. Okay, W. So we put the y1 here, y2 here, and we differentiate y1 with respect to x, we get a y1 prime. Okay, y2, we differentiate y2 with respect to x, we get a y2 prime. So this is a matrix. This is a matrix, 2 by 2 matrix. This is determinant. So if we want to find for the determinant of a 2 by 2 matrix, we use AD minus BC. Right? AD minus BC. ABCD. AD minus BC. So for example, this one, let's say this one. If we want to find the Wronskian in between y1 and y2. Y1, y2. So differentiate x, we get 1. Differentiate ex, we get ex. AD minus BC. This is the Wronskian function. Okay, AD minus BC. So if if y1 and y2 are linearly independent, meaning that your Wronskian function is non-zero. It will be non-zero. Wronskian function is non-zero. Okay, let us try this. Ex and 2ex. Let's see what's happened. Ex to ex. So differentiate this, you get ex. Differentiate this one, you still get 2ex. So AD minus BC, 0. When your Wronskian function is 0, means that your y1 and y2 are linearly dependent. Or we use another sentence. When your Wronskian function is 0, it means your y1 and y2 are not linearly independent. Okay, what we want is linearly independent. Okay, so there are some exercise. When we try to get the Wronskian function. Question number 1. Ex negative 3ex. Ex and negative 3ex. Okay, try to compute the Wronskian function. Okay, the question is, determine if each of the following pairs of y1 and y2 are linearly independent. Okay, we want to determine whether this pair is linearly independent or not. Okay, so you compute for the Wronskian function x negative 3ex. You differentiate these two and put them here. Apply the AD minus BC. Okay, apply the AD minus BC.
Y1 and Y2 equals to 0, it's independent, yes? Y1 and Y2 equals to 0,
if Wronskian equals to 0, then y1, y2 are linearly dependent. Linearly dependent. 0 equals to 0 is dependent. Okay.
So try to answer this one.
Yes, fine. It is hands-on and box. Okay. So when you differentiate ex, you get ex back, right? Differentiate this, you get ex. Differentiate this one.
3x.
Negative 3 ex. Okay, AD minus BC. AD, you get a negative 3 e to the power
X.
2x. You sum up the x, right? X plus x. Okay, minus. Okay, minus. This one multiplied with this. You have negative 3e 2x.
The same.
The same. So that's why you get 0.
0.
0. So the conclusion is y1 and y2 are not linearly independent. Because the question is asking whether they are linearly independent. Ex, x, ex. X, x, x. Okay, this is number 2. This one you have to apply the product rule. This is y1 is ex. Ex, y2 is x for x. So your W is 1. So differentiate ex to get the x. Differentiate x ex. Okay, we use product rule. Okay, product rule. Differentiate x, we get 1. Copy ex. Plus, now copy x. Differentiate ex, we get ex. Okay, so AD. AD minus BC. This one, we get e2x plus x e2x minus x e2x. Okay, so you get an e2x which is not equals to 0. Exponential function, you can never get 0, no matter what is the value of x. Okay, so it is not 0 for all x. Okay, so the conclusion is y1 and y2 are linearly independent. Okay, any questions for number 2? Are we done? Question 2, number 3. Two x negative sin x. Okay, AD minus BC. Okay, AD minus BC. And this function is not equals to 0 since x is not 0. Right? This is even in the question. X is not 0 is even in the question. If X is not 0, that's mean you can't get 0. Okay, it will not be 0 as long as your X is not 0. Okay, clear?
For clear, the X not 0, I the independent.
Yes, because X is non-zero, so
So
you won't get 0.
directly.
Yeah. You will never get 0. This point, you will never get 0 since X is non-zero. Okay, what's happened? What's happened if this is not given?
I must solve the same.
Yeah, you have to tell the same, but you need to give the conditions. Okay, if this is not given, if this is not mentioned, okay, if this is not mentioned, so your solution will be stopped here, right? This one, this is your solution.
Yes.
Okay, this one is non-zero when this function is non-zero when X is non-zero, right?
Yes.
This means if this is not given, your answer will be this one. This is non-zero when X is non-zero, right? So your solution will be y1 and y2 are linearly independent when X is non-zero. Okay, other than that, it will be 0. Okay. Okay, any questions? Linearly independent, Ronsians? Okay, if no question, we move on to the generalized superposition principle.
That's okay.
Y1, Y2 are linearly independent solutions. Okay, next one, we look at this. This is a second order differential equation. Okay, homogeneous differential equations. And let's say y1 and y2 are linearly independent solutions for this differential equation. Then, according to the generalized superposition principle, okay, the linear combination of these two, okay, linear combination means we can combine these two linearly. Okay, that means here we use okay, in the knots, I follow the knots. Okay, A y1 plus b y2, A and B are constant. This is called linear combination of y1 and y2. So the linear combination of y1 and y2, this one, is also the solution of this OBE. Okay, I repeat, if y1 and y2 are linearly independent solutions for this differential equation, meaning that the linear combination of these two is also the solution of this. And this is called general solution. Okay, general solution. Okay, exercise. Y double prime. Y double prime plus 9y equals to 0. show that, okay, question A, show that y1 and y2 are solutions of the differential equation, cos 3x, cos 3x, sin 3x. Okay, you refer to the slide. Question A is show that y1 and y2 are solutions to the differential equation. Okay, how do we show y1 is the solution of this? Okay, if y1 is the solution of this differential equation, meaning that it will satisfy the differential equation. When you differentiate this twice, you substitute here, and you substitute your y into here, you get 0. Okay, if this is the solution. So this is how we show whether it is a solution of the differential equation. So you find what the y prime and y double prime. So differentiate this, you get a -3 sin 3x. Differentiate once again, -9 cos 3x. Okay, then we write the left-hand side of the differential equation. If we write the left-hand side of the differential equation, then we start to substitute. Y double prime is this one. Plus 9. Plus 9. Y is cos 3x. So what do I get? 0, right? You get 0, which is the same as this right-hand side. Okay, so we have done show that this is the solution of this differential equation. Now do the same to the y2, because we want to show both of them are the solutions of the differential equation. Do the same to this y2. Y2 prime, y2 double prime. Then substitute into the left-hand side of the differential equation. Okay. So differentiate sin 3x, we get 3 cos 3x. Differentiate once again, negative 9 3x. Okay, y double prime. Plus 9y is sin 3x. Okay, so you get 0, which is the same as the right-hand side. Okay, this is how we show. Okay, this is how we show that the solution is the differential equation. The function is the solution of the differential equation. Okay. We cannot. Okay, this one. This is counter example. We cannot show like this. Okay, we can't show like this. This is the wrong way. Okay, because some students make mistakes, something like this. Okay, why this is wrong? Because now we are in the process of showing, we want to show that this fits to this differential equation. So we substitute on the left hand side and we aim to check whether the right hand side is the same or not. So if you start from here, equals to 0, you substitute your y double prime and y, and then equals to 0, meaning that you have already assumed this is equals to 0. We are not assuming they are equals to 0. We want to check whether they are equals to 0. Okay, so this is not a way. Okay, this is for A, question A. Now, question B. We want to show that y1, this y1 and y2 are linearly independent. Okay. B, for B, we want to show this y1 and y2 are linearly independent. Okay, so y1 is cos 3x. The x, y2 is sin 3x. Okay. For question B, we want to show that y1 and y2 are linearly independent. So we find what the Wronskian function is. And we show that the Wronskian function is not equals to 0. Okay, linearly independent. We want for question B, show that y1 and y2 are linearly independent. Okay, so what is your Wronskian? What's your Wronskian function? Differentiate cos, we get negative sign.
Negative sign.
Okay, differentiate sign, we get positive cos. AD minus negative 3 sine square 3x. Okay, this means 3 cos square 3x plus 3 sine square 3x. Okay, we can factorize the 3. So what we have is cos square plus sine square with the same angle, which is 1. Okay, cos square plus sine square with the same angle equals to 1. Okay. Any questions?
Yes. Where does this 3 come from? It's minus 3.
Minus 3.
Yeah, it's differentiate.
When you differentiate this one,
Yes.
differentiate cos, you get a negative sign.
Yes.
Yeah. You need to differentiate this one.
Yes. 3.
You get a 3, you put it as.
And the 3x comes down. And the 3x comes down. 3 and 3 and 3x comes down.
Differentiate the angle.
Well, I guess I'll just see this.
Okay, any more questions?
You wrote this one. I wrote this one.
Then
The step before the last one. They ask you on the fact list.
there's an identity cos square theta plus sine square
Equals to one.
theta equals to 1.
Yes, it says.
This is the identity. Because here we have cos square and sine square with the same angle, right? These two are the same. That's why this is equals to 1. Okay, this equals to 1. Okay, C. Okay, question C. Okay, question C. Now we want to show that this okay, question C. Show that this linear combination of y1 and y2 is a general solution of this differential equation. Okay, we want to show that this is a general solution of this differential equation. So we follow the same steps, find for the y prime and y double prime, substitute only to the left hand side and check whether the right hand side is 0. The y prime plus we get negative sign. So negative 3a sine 3x plus sine we get positive cos. So 3b cos 3x. Okay, differentiate once again. Okay, sine we get positive cos, but because we have a negative here, so we still have negative. So 9a cos 3x. Differentiate cos, we get negative sign. Okay, negative. So 9b cos, you get sine. Okay, then substitute the y double prime and 9 and the y into the left hand side function. Y from here. Negative 9a, positive 9a with cos, then negative 9b and positive 9b with sine, get 0. Any questions? Differentiation? Steps. We want to show that this is the solution of this differential equation. So we have to differentiate twice because we have y double prime, so we have to differentiate until y double prime. Then we substitute y double prime, this one, into here, and the y is into here. So check whether the right hand side you get 0.
So it's linearly independent or not linearly? It's linear. Independent or not?
0. This one equals to 0. And we have shown that this is the general solution of this one. Okay, it's shown here. Y equals 0. If this is 1, you should get a 1 here. If this is 5, you should get a 5 here. If this is x, you should get an x here. Because the left-hand side must same with the right-hand side. What you obtain here must be the same with the right-hand side. It's not about 0. Okay, it's not about 0 because coincidentally here is 0.
0 after negative.
No. This 0 is nothing to do with the linearly independent. So that is the one here. Okay, so no matter which type of differential equation, whether homo or non-homo, non-zero, this is the way to show that that solution, that function is the solution of that differential equation. Just differentiate. Okay, differentiate and then you substitute to the left-hand side. Substitute to the left-hand side and see whether you get the right-hand side function. Okay.
You have to differentiate what? Continuous, so you have to differentiate what, then we back to the weighting, after the applied force level is from the differentiate. That's it.
Yes. If this is the first order, okay, if this is first order, this means you just need to differentiate once. If this is the first order, if this is the third order, we differentiate twice, 3 times. 3 times. And substitute accordingly. Okay, any more questions? So from here, you know that throughout this course, the solution that you obtain, if you want to self-check, if you want to do self-check whether your solution is correct or not, use this way. Because for this course, you are solving a differential equation, and if you get a solution, a final solution in the function, okay, in the function form, then you can do the self-check by using this step. Then you know whether your solution is correct or not. Okay. Okay, next, we want to see how to solve this kind of differential equation. This is a second order linear differential equation and linear homogeneous differential equation with constant coefficient. Okay, so for this type of differential equation, for example, you have 2y double prime plus 3y prime minus 4 equals to 0. Okay, if you have this kind of differential equation, we will solve using this way. Okay, so how to solve? We will come up with the characteristic equation. Okay, characteristic equation is am squared plus bm plus c equals to 0. This is a quadratic equation. Okay, quadratic equation where you just take the a, b, c from the differential equation and form this. Double prime, you have m squared. Y prime, you have m. The one with y, you don't need to write anything for the y. If we just extract the values of a, b, c and substitute into this to get a quadratic equation. So for example, this one, what is the characteristic equation for this? 2 m squared plus 3 m minus, sorry, there's a y here, minus 4 equals to 0. So this is the characteristic equation for this differential equation. Okay, next, we will factorize. We will factorize the quadratic differential equation to get the two values of m. So m1 and m2. factorize. So this one you can either factorize manually or you use your calculator to get two values of M1 and M2. Okay, then we will refer to table 2.1. If you look at the slide, we will refer to table 2.1 to get the general solution. Okay, what is the table 2.1? So you have three cases. Okay, you have three cases where this is case. All right, for case one, okay, this is your M1 and M2. Okay, for case one, if your M1 and M2 are real and distinct. Real and distinct. Distinct means different. Okay, different. Real means there is no I, no complex number. Okay, real and distinct. For example, M1 is 3, M2 is 5. Real and not the same. Okay, and your general solution. Okay, your general solution, it will be y equals to, we give a constant. Okay, we use constant C1. C1 exponential function and 1x. Okay, the first and 1x plus C2 E and 2x. So if you find your M1 and M2 falls under this case one, which is real and distinct, so this is your general solution. You just put the values here. Okay, so based on this one, your solution is C1 E 3x plus C2 E 5x. Okay, so this is case one. For case two, if your M1 and M2 is real and the same, real and the same. For example, M1 is 2, M2 is also 2. They are real, okay, real, no complex number, and they are the same. So case two, it will be y equals to C1 E M1x, okay, plus C2. Okay, the second one, you need to insert an extra x, E M2x. This is actually, case two is actually similar to case one, where you need to substitute the M1 and M2 for the exponential function. But because of this is same value, so the second term you need to insert an extra x. Why we need an extra x? Remember this, your y1 and y2 comes from here. Okay, this is a general solution. This is a general solution. So this is your y1. This is your y2. If these two values are the same, if these two values are the same, that means, for example, EX, your y1 is EX, your y2 is EX. Then your y1 and y2 are no longer linearly independent. Remember what you have learned just now? Your y1 and y2 must be linearly independent. So that's why we can't use this formula for the case of real and the same. The second term must have an extra x, so that y1 em1x and y2 is x e m2x. These two are linearly independent. Okay, we insert an x because we want them to be linearly independent. So for second case, when you see the same values for m, remember to insert an x for the second term. Okay, so for this case, okay, the answer will be C1 E2x plus C2 x E2x. And one last case, case 3, if your m is complex number, alpha plus minus beta I. If your m contains a complex number, that means your y will be e to the power of alpha x. Okay, in the bracket C1 cos beta x plus C2 sine beta x. E alpha x, C1 cos beta x plus C2 sine beta x. For example, let's say your m is 2 plus minus 3i. 2 plus minus 3i. So your alpha is 2. Okay, alpha is 2, beta is 3. Your beta will be a positive value. Okay, because your m is alpha plus minus beta I. Right? Alpha can be negative value, but your beta must be positive value. Because we are taking the beta from here. From this 3. Plus minus, right? The beta must be positive. So according to this case, the answer will be alpha here will be 2. E2x, okay, in the bracket, C1 cos 3x plus C2 sine 3x. Okay, so it depends on the value of the values of m that you found from the quadratic equation. Okay, now we try the exercise. Okay, try to write down the characteristic equation. Then factorize. What's the sign for the attendance? What is the characteristic equation for this A? Y double prime, we have m squared minus m minus 6 equals to 0. Okay, then you can factorize either manually or from your use your calculator. Okay, so what is your m?
Can we do the calculation?
Yeah, you can use the calculator.
So how can I do it?
Is any number here? Degree 2.
Well, yeah, I mean, further, one there's no. There's no any. So minus, it will be minus 1. See, minus 1. M, it's only 1. That's about it. One only one. One C is minus.
It does.
Minus. M squared. Minus one. Minus one. They have a 6 minus 6. Because so M1 is a 3. X one is a 1. X2 is a 2. Yeah, maybe saying. The initial is
We haven't got values. Please make sure if you do not know how to manually do the factorization, please make sure you know how to use your calculator to get these values. Okay, this one you can use this as M1, this as M2, or this can be M1, this can be M2. It doesn't matter. Okay, the order is doesn't matter.
Let's say this one is actually this one.
This is the basic of part 2. Basic part 2, you will use this one is the basic. So this is case. This case 153. Case 1, right? Real and distinct, not the same. So your line will be C1 E 3x plus C2 E negative 2x. Okay. So if this is your M1, this is your M2, that means this is negative 2, this is 3.
But it's not the same. Because it's not the same, right?
This is not the same, and there is no I. That's why we follow the first case. Okay, B. Try B. C. Okay, this table is not even in any of the assessment. That's when you have to remember this. This is not even either in midterm or final. Yeah, not even. All the while, this is not even.
The rest of it while equals and
For the general.
let's fix that. Y equals to the.
Yes, the last step is to find the general solution. This is the general solution based on different case.
Yes. Oh, we must save this. We must save this thing.
Yes, you must save this thing in your brain.
We said we must save it, like extend the question to save it.
This is which one? Real and distinct. Distinct means not the same. Not the same. So real and distinct. This is real, no I, and distinct, not the same. So this is the solution. You just substitute your M1 and M2 here. Okay, B. And square minus 8n plus 16 or equals to 0. Okay, have you get your M1 and M2?
Yeah.
4. Both are the same, right? Do you get this?
Yeah.
So this is case 2. Okay, case 2. So your y is C1 E or X plus C2, insert an extra X, E or X. Okay, because they are the same, real and the same. So the second term has an extra X.
This one is more. This one is more expensive than this. And this one is 16. One. What brother? Oh, hey, for you. Where is it? Fresh one? 16, huh? Minus 1. Only minus 1. Minus 1. How's that? Say minus 4, yes? Yeah, that's like 1. Only minus.
Your B is not 8, your B is negative 8.
Negative 8. Minus 8. Minus 8. Minus 8. Minus it is simple. Thought. So when it's small, so whatever you have is for the same. Okay, what we now yeah, the two values are the same. So,
What about C? C, you get it? Complex number, right? Complex number. What is your M? What is your alpha? Alpha is -1 plus minus, what is your beta? The 3R. Okay, sum of the calculator, it gives you the values in decimal. Okay, in decimal. Sum of the calculator, the more advanced, okay, it will give you the sub-3. Okay, try using your calculator because different models of calculator, it shows a different display. Okay, different display. So you must try and check your own calculator. This one is the advanced one.
yeah, well, you took the other
Calculator, okay, for the calculator that you see only -1. Okay, on the screen, if you see only plus, look at here. If your calculator shows only the -1 here, you look at the right top, you will see the IR. If you see this, meaning that it is a complex number.
Yeah.
And you need to click on the shift answer. If not mistaken, you look at the button of a answer up there. Answer is up here you see the IR, is it? So you click on the shift answer, you will see this or 2.7 something.
Yeah.
Oh, not ANS, the equal button. The equal button up there, you see this sign, right? I interchange with R. I just look at the one is a three. The one is a three. No, this one. This one. This is one line. This is the next one. Next one is minus this one. It is the same as this one. Negative one plus minus.
No need to make this.
I just like negative one plus minus.
That's it.
It's fine with an R. Second.
Much easier.
One, and then two,
We need this animal. Or next time. You have start is more. I think that I'm going to try it. The game is second city movements, but then just
the same line.
Yeah, smart. But which is it? So what if I decide? See you in mind. I'm sorry. Yes.
How about you? You have
Well, I just.
actually, I think that's.
So this one, actually if you look at your calculator, your N1 is -1 plus 3i. Your N2 is -1 minus 3i. One is plus, another one is minus. That's why we just write in this form. One is plus, one minus. Okay, when this is a complex conjugate, we just write in this form. This is easier for us to see. This is your alpha, this is your beta. So you substitute your alpha and beta here. So your y is e to the power of -1x. And then C1 cos Z3x plus C2 sine Z3x. Z3x. Just substitute the values. This is your alpha, -1, beta here. Then you get the solution.
So this is the value equal 0. Sorry.
Equals to 0.
Yeah. This value last one.
What is equals to 0?
Equals 0 or less than.
Equals to you mean this one?
Yeah.
No, it's not equal
This
to
is
0.
the answer.
This is the answer. Okay. Any more question regarding your calculator?
For now.
Okay, you have to try it. You have to try using the real calculator, but not the mechanical. Okay. You have to try using your calculator. Okay, B. What is the characteristic equation?
And
M squared minus 4.
yes, you know, equals 0.
There is no M here. There is no M here. This is another careless mistake. No M because there is no Y prime.
Yes.
Okay, no Y prime. Okay, this one, when you stop, what is your M?
0.
What is your M1 and 2? Your M1 and M2, plus minus 2, right? Plus minus 2. Right? Try to use your own calculator. You should get the plus minus 2. So this is the first case, right? First case, real and distinct. So C1 E2x plus C2 E -2x. Okay, you get this. But this question, it comes together with the initial values. Okay, initial values are given to find what the values of C1 and C2. Okay, for C1 and C2. So now you substitute this one. Why we apply this one first? When x is 0, y is 0. Meaning that when x here is 0, y will be 0. You substitute the x0, y0 into this. So C1 E0 plus C2 E0, right? So E0 is 1. E0 is 1. So meaning that from here you have one equation. You get one equation. Then we apply the second initial value. The second initial value is y prime. So before you apply, you have to get the y prime. Okay, you have to get the y prime first. The y prime is, you differentiate this one, you get 2C1 E2x. Okay, minus 2C2 E negative 2x. Okay, once you have got your y prime, then you can start to apply this. Y prime, you know, is negative 1. Okay, so y prime 0 equals to negative 1. It means when x is 0, your y prime is negative 1. Okay, y prime is negative 1. When your x is 0, so 2C1 E0 is 1. Minus 2C2 E0 is 1. Then you get the second equation. So with the first equation and second equation, you solve these two simultaneously to get the C1 and C2. And lastly, put the C1, C2 values back into your solution here to get the final solution.
Francis got the question.
So to solve this two, okay, this one, this is C1 equals to negative C2, right? C2 is negative C2. But C1 is negative C2. Then you substitute into here, negative 1 equals to 2 C1. So C1 is now negative C2 minus 2 C2. Okay. So negative 2 minus 2, negative 4 C2. This means you have get your C2, which is 104. When the C2 is 104, here, your C1 will be
Minus what?
right? Your C2 is 104, so C1 is negative 104. Then put this 2 back into this. Your y is negative 104 E2x plus 104 E negative 2x. Okay, this is the final solution. So when you let this be your M1, this one is your M2, here will be negative 2 and plus 2, right? But after you apply the initial values, you will get the same answer. No matter which one is your M1, M2, you will get the same answer after you find the given initial values. Okay, any questions?
Here we get from the question is. Here equals to C1. Yes. If you were this one, this is same.
This one?
Same like the bottom. Same like 0 is
0 equals C1.
0 equals C1.
this one is from the question. Yes. How do you make the difference?
How to get this? From here. This means x, when x is 0, y is 0.
So why is it?
So y is 0, x is 0. That's why x 0, y also 0. Okay, question E.
This one. This minus y equal to C. Beta again.
Minus 1
Yeah, equal to C.
to C1. This is the second initial value.
Yeah, after that.
This means when x is 0, y is y prime is -1.
Yes.
So y prime is -1.
Yeah.
This is 0. E0 is 1. So you have to choose 1.
Then how
Because you have two equations now. You have two equations now. You want to solve to get a C1 and C2.
yes.
So this one you can write in this form. C1 is negative C2.
Yeah. So that
Then your C1, you replace the C1 by negative C2. This C1 you replace by negative C2.
so you
Now this is in single unknown, then we can get the value of the C2. Okay, E m squared plus 4. M squared plus 4. So what is your M? M1, M2. Which case? Prime E, what is your M1 and 2? Which case? Which case? Case 3.
yes,
Nice.
yes, 3.
Complex. So what is the alpha and beta? Alpha is 0. Okay, let's try you use your calculator. Try using your calculator. Do I can see the I need. So plus minus 2i. Right? Plus minus 2i. This means your alpha is 0. Right?
Yes. The same.
Yes.
But
So means that there is no value in front of the imaginary part. No value means alpha is 0.
So only we have beta.
Alpha is 0.
And beta is minus
Beta is 2.
2.
Beta is 2. You just take this value. Okay. So your y is e to the power of 0, right? Okay, I write the full one. E 0 and then C1 cos 2x plus C2 sine 2x. Okay, you have the e to the power of 0 because of formula. Okay, formula E alpha x, but your alpha is 0. Okay, that's why your answer is, your general solution is this one. Okay, then you can start to substitute the initial values. So when x is 0, y is 0. So y is 0. C1 cos 0 plus C2 sine 0. What is cos 0? What is cos 0?
1.
1. Sine 0?
1.
0. Sine 0 is 0. So 0 and C2 is still 0. It means that you have found your C1. Okay, you have found your C1. And next, we want to apply the second initial value. Okay, so either you substitute your C1 first to get the latest Y, then you proceed to differentiate, or you differentiate, then substitute this one. Okay, either way.
Not when the x0 y is 1.
Okay, let's say we want to substitute, okay, without updating the solution, then it means you find for the differentiation for y. Okay, so differentiation for y is negative 2c1 sine 2x plus 2c2 cos 2x. Then you substitute this. Y prime is 1. X is 0. Negative 2c1 sine 0 plus 2c2 cos 0. Cos 0 is 1. Sine 0 is 0, meaning that c2 is half. Okay, now you get your C1 and C2. Update your final solution. C1 is 0, so this term is gone. Okay. What is your
Half and negative 4. Half and negative 4.
half and negative 4?
Yes.
Okay, so this is case 1.
And that's like understand the effect of the condition. The direction. Thank you. The thing is, For me, I can't. So it's good. Send that coming from don't show me. All after this. Thank you, appreciate it.
V1 in terms of V2, or you can solve them simultaneously. So when you obtain C2, then get your C1. C2 is -1/3. So 1 plus 1/3 is 4/3. Okay, then write down your final answer. C1 4/3 E half x minus 1/3 E -4x. Any questions? Suppose this question you know how to solve. Okay, after question A up until suppose this one you know how to solve.
We hope so.
If you look at the past year question, normally question number 1, normally question number 1 part A, you will see something like this. This is the simplest one.
Really?
This small thing is the simplest one. Now, you see question number 1, part 1, normally the simplest one, right?
Yeah.
This is the basic for next class. Okay, this is the basic for the next class. I want to show you the past year question, but the projector is not working. My laptop. It's okay. I show you on next in the next class Friday.
How to class a week?
Yeah. One subject to pass 2 spots per week for 3 credit hours. Okay, any more questions? We have done the topics for week 3. This is week 3. Next class, we will start the week 4 topics. Okay, next week, I'm sorry, next week. Next class, we will look at the part 2, which is the topics of week 4. Okay, part 2, that means when this is no longer 0, okay, then you will learn 2 different methods. Okay, 2 different methods to solve non-homogeneous second order linear differential equations with constant coefficients.
How to find that?
Okay, for ULearn, if you enroll yourself in ULearn, you will find that there are 2 different slides, right? One is the slides from me. Okay, this is the slides from me. Another slides is OCW slides. OCW slides are slides produced by a group of mathematics lecturers. I'm one of it. Okay, in OCW slides, you will see more examples for each of the subtopics. Okay, more examples.
Like
Less exercise, but mine
Or maybe
almost all are exercise because I want to have hands-on in the class. Okay, that's why I'm using, all the exercises I'm using is from my slide in the class.
So after you study that slide, go back to
Yeah, you
study
can.
the exercise.
I don't use OCW sites in the class. The OCW sites is for your own reference.
Yeah, in the home.
You can download and go through it.
There is a YouTube video on site. There's a YouTube video on site.
Yeah, not looks like you like it's size wise answer.
The problem I'm you know
I understand. I was